Okay, question 1, part B. Denary numbers are converted to binary numbers to be processed by a computer. Convert these 3 denary numbers to 8-bit binary numbers. So, important thing about reading questions is there's an extra bit of information here which will prevent us from losing marks, because our answers have to be 8 bits. So we need to remember that, and at the end we'll just check that each one is 8 bits. But let's go ahead and start working them out. So you've got a working out space down here, and you will have more space than me because of the way I've done this as a PowerPoint. So I'm going to go ahead and start writing my answers across on the right hand side. So we're going to start off with 50. So that's a denary number that we need to convert into a binary number. So there's a very mechanical process that we can use here with this. And the first step is to draw a table. The table will start off on the right hand side for 1, and then we double the numbers as we go from right to left. Okay, and that's really important. I have seen some students that start the table with a 1 on the left hand side. So for example, they might do this and then do it that way, and that's wrong. Okay, so we start off with a 1 on the right hand side, and then we just double the numbers. And what we're going to do is, because the number that we want is 50 here, we're going to keep doubling until we get a number that's bigger than 50. So 1, 2, 4, 8, 16, 32, 64. I'm going to stop now because that is bigger than 50. And the reason we're stopping there is because it's going to keep the maths as simple as it needs to be, or as difficult as it needs to be. We don't need to do any more processing. Right, all we're going to do now is we're going to take each number in the table, starting with 64, and see if we can take it away from 50. So 50 minus 64 we can't do. We can't take 64 away from 50, so we're going to pop a 0 there. Now we're on 32. We can take 32 away from 50, so I'm going to pop a 1 there, and then I'm going to do the sum. So 50 minus 32 is 18. Okay, it's really important that you work out this remainder properly and carefully. Right, then we move on to our next number in the table. We've got 16. We can take 16 away from 18, so let's go ahead and do that. We have a remainder of 2. Okay, we can't take 8 away from 2. We can't take 4 away from 2, but we can take 2 away from 2, so we're going to pop a 0 in there. Work out our remainder, which is 0. We can't take 1. Let's do it over there. We can't take 1 away from 0, so we put a 1 there. And that's our first answer. We'll write the answers into the answer box in a second. Let's work the next one out. Let's do 102. So that one's for 50. Let's do 102. So we're going to do our table again. Start off on the right hand side, do a 1, double the numbers, 1, 2, 4, 8. The reason we're doubling the numbers is because it's binary and it's base 2, which was in the previous question, so it's powers of 2. But it's easier just to remember doubling the numbers. So we've got 16, 32, 64. This time I'm going to stop at 128, because 128 is bigger than 102. So remember, just keep doubling until you get to a number that's bigger than the one you're converting. And then we'd simply try and take away the numbers in our table away from the number we're converting. We can't take 128 from 102, but we can take 64. So I'm going to pop a 1 there, and let's go ahead and work out our remainder. Okay, so we've got 38. So 102 minus 64 is 38. Okay. Then let's move along. So we've done those two. Let's move along. So we're on 32. Can we take 32 away from 38? Yes, we can. So let's go ahead and do that sum. So 38 minus 32 equals 6. So generally the maths is fairly straightforward, because you can't use a calculator, so it needs to be, it's not a maths test. You're being tested on your ability to convert from denary to binary, binary to denary. Right. So we're left with 6. Can we take 16 away from 6? No, we can't. Can we take 8 away from 6? No, we can't. So I'm keeping track of my numbers here. Can we take 4 away from 6? Yes, we can. So we're going to pop a 1 in there. We've got 6 minus 4 leaves us with 2. Can we take 2 away from 2? Yes, we can. So 2 minus 2 leaves us with 0. Can we take 1 away from 2? No, we can't. That's our next answer. So we've just got the last one to do, which is 221. So we're going to do our table again. So we got 1, 2, 4, 8, 16, 32, 64, 128, 256. Now we're going to do our sums. Can we take 256 away from 221? No, we can't. Can we take 128 away from 221? Yes, we can. So we pop a 1 in there and we're left with 93. Can we take 64 away from 93? Yes, we can. So we pop a 1 in there and we're left with 29. Can we take 32 away from 29? No, we can't. Can we take 16 away from 29? Yes, we can. And we're left with 13. Can we take 8 away from 13? Yes, we can. So that leaves us with 5. Do our remainder again. Can we take 4 away from 5? Yes, we can. Leaves us with 1. Can we take 2 away from 1? No, we can't. Can we take 1 away from 1? Yes, we can. So let's write our answers in the answer space. So for 50, we've got 0, 1, 1, 0, 0, 1, 0. It needs to be 8 bits. We've got 1, 2, 3, 4, 5, 6, 7. So we need to add an extra bit. We add it on the left-hand side because that doesn't affect the size of the number. The next one, we've got 0, 1, 1, 0, 0, 1, 1, 0, 1, 2, 3, 4, 5, 6. That is 8 bits. And then for the last one, we've got 1, 2, 3, 4, 5, 6, 7. Now, for the last one, if we write it in, we've got, which is actually 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, that's 9 bits. So we actually need to take off that extra 0. And if we look at the answers for that, we've got 0, 0, 1, 1, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0. So I'm looking at these here, that's correct. And then we've got this one here, sorry I've written over them, 1, 1, 0, 1, 1, 0. That's all good.